Hi, I'm Benjamin Beach, and I'm starting something new on my channel where I explain the coolest things in science to you. Now today we're going to start with something that's very close to my heart, but even closer to my brain. Time travel. This is Ben Beach Science. Time travel has appeared throughout the ages in Hindu and Japanese legends, and even more modern stories like Rip Van Winkle. But the first, what's considered modern interpretation of time travel is H.G. Wells' The Time Machine, which famously had a machine that looks like this, that could travel through time but not space. But the big question for science has always been, is time travel possible? Today I'm not only going to show you how time travel is possible, but how it's not as far-fetched as you may think. To understand time travel, you need to understand a few key concepts. The first is the fourth dimension. I don't mean the fourth dimension as in, there is a fourth dimension beyond that which is known to man. No, I mean the fourth dimension as in the dimensions of space. You probably learned in school that there were three basic dimensions of space: length, width, and height. So, for example, you can measure a cube in length, width, and height, and multiply those to find the volume. Now, if we have a cube, and we can say it's 2 units by 2 units by 2 units, that doesn't just describe the cube. We can say the cube is 2 minutes by 2 minutes by 2 minutes at 7:30. Now, that fully describes where the time is in space, and it is in time, fully describing its position. So, to recap, we have the 3 dimensions in space, but we have the 4th dimension of time. The other key concept you have to understand is that space and time are the same thing. That's why time can be a dimension of space. Now, Einstein gave us this idea called space-time. You may have heard of it. Space-time continuum, ringing any bells? He told us that, like I said, space and time are actually just one thing, that we sense as 2 different things. So anything that should affect space should also affect time. And what affects space more than gravity? Gravity can pull space down, it can slow space. And when gravity pulls space down, it's also pulling on time. So theoretically, to time travel, all you have to do is pull on space enough, where you're also pulling time. Now, how do you get that much gravity? Well, one possibility is black holes, super dense, super gravity, collapsed stars. The only problem is if you go in a black hole, you'll probably be atomized and die, so that's not the best possibility. Other ideas are some complex space geometry, but the one we're going to focus now is speed. Now you're probably asking, how could I get really heavy with really gravity with speed? The thing is, we're moving slowly, so it's pretty imperceivable to us. Even though we think our race cars are really fast, in the scheme of things, they're not. I'm talking about in monumental speeds, like the speed of light. The faster you travel near the speed of light, the more massive you will become. So, if we had a spaceship, theoretically that could travel at 90% the speed of light. Now this is not possible. Well, today, I would like to point that out. It would require a large amount of energy, much larger than anything we have now to go that fast. But hypothetically, if we could, we would become super massive. Because we're super massive, that also means gravity has a super big effect on us. Because gravity has a super big effect on us, time for us is moving very slow. Now you're thinking, okay, we're slowing down, but that's going to be like the Matrix. That's not going to help us time travel. Ooh, you could not be more wrong. On Earth, time is moving at the constant speed we're used to. Time for Earth is going to be 1 second per every 1 second. So basically it's going to be time. But for us on our light speed spaceship, time is not going to be moving. It's going to be moving, say, 1 second for every half second. That means for every 1 second that passes on Earth, 2 seconds passes for us. That means Earth is aging twice as fast as we are. So when we land on Earth, everyone around us will be, say, 10 years younger. But we will only be 5 years younger. Which means we traveled 5 years into the future. There you go, time travel without a flux capacitor or a TARDIS. All you need is a spaceship with an unlimited amount of energy. Thank you for watching this edition of Ben Beach Science. If you would like to suggest future topics, comments below. Please like, comment, and subscribe to spread this video, and always keep getting smarter.